projects. In this video, we are going to explain about a project titled A Deep Neural Framework for Continuous Sign Language Recognition by Iterative Training. Coming to the introduction part, in recent years, significant progress has been made in developing sign language recognition systems using deep learning techniques. One promising approach to address the intricacies of continuous sign language recognition is the use of iterative training in a deep neural framework. This approach leverages the power of deep learning models to efficiently learn complex patterns within sign language gestures, making it feasible to recognize signs within a continuous stream accurately. In this research, we propose a novel deep neural framework designed explicitly for continuous sign language recognition by employing iterative training techniques. The key objective of this study is to improve the recognition accuracy and robustness of the system, enabling seamless real-world applications and enhancing the communication experience for the deaf community. The main contributions of our research are iterative training strategy. We introduce an innovative iterative training strategy that enhances the model's ability to learn temporal dependencies and spatial patterns present in sign language gestures. Temporal modeling. Recognizing continuous sign language demands a profound understanding of the temporal evolution of gestures, real-world application. Throughout the research, we maintain a focus on real-world applicability, ensuring that the developed deep neural framework can be integrated into various devices ranging from mobile applications to assistive technologies, thus supporting the daily communication needs of the deaf community. So our main objective for this project of a deep neural framework for continuous sign language recognition by iterative training is to advance the state of the art in continuous sign language recognition by combining innovative deep learning techniques, iterative training, temporal modeling, spatial feature learning, multimodal fusion, and a strong focus on real-world applicability and inclusivity. The specific objectives for the researchers are improved recognition accuracy. The research aims to achieve higher accuracy in continuous sign language recognition compared to existing approaches. Spatial feature learning. The research aims to design specialized convolutional neural networks, that is CNNs, to extract discriminative spatial features from video frame real-world applicability. A significant objective of the research is to ensure the developed deep neural framework is practical and can be applied in real-world scenarios. The system should be compatible with various devices and platforms, making it accessible and used for the deaf community in their everyday communication needs. Now coming to the requirements, there are two types of requirements, that are hardware requirements and software requirements. So hardware requirements are operating system, that is Windows only, processor i5 and above is required, minimum 4 GB of RAM is required, hard disk 20 GB and above is required. Talking about the software requirements, Python IDEL, that is 3.7 version is required. Coming to the methodology part, first we have upload Signum sign language dataset. In this, we have dataset. This refers to the first step in the sign language recognition process. To create a sign language recognition process system, you need a dataset containing video recordings of people performing various signs in the sign language you want to recognize. The dataset is likely to include examples of different signs, gestures, and facial expressions commonly used in that sign language. By uploading the Signum sign language dataset, you are making this collection of sign language videos available for use in the subsequent steps of the process. Second, pre-processed dataset. Data pre-processing is a crucial step in building any machine learning model. In this context, pre-processing the Signum sign language dataset involves various tasks to make the data suitable for training a neural network. Common pre-processing steps for signing language recognition might include video frame extraction, convert videos into individual frames to work with images, resizing and normalization, that is, resize the frames to a consistent size and normalize pixel values to a common scale. Data splitting, divide the data set into training, validation and testing sets. Label encoding, convert sign labels into numerical representations. Data augmentation, which is optional, increase the data set size by applying transformations like rotation, flipping or shifting to the images. Third, train CNN, BI, LSTM neural networks. Once the data set is pre-processed, the next step is to design and train a neural network model to recognize signs from the pre-processed videos. In this case, the model being used is a combination of convolutional neural network, that is CNN, and bidirectional long short-term memory, that is BI-LSTM networks. CNNs are effective in learning spatial features from images and have been successful in various computer vision tasks. BI-LSTMs are a type of recurrent neural network, that is RNN, that can be capture temporal dependencies in sequences, making them suitable for time series data like videos. Fourth, upload video and recognize signs. This step involves using the trained CNN BI-LSTM model to recognize the signs in new, unseen videos. You can upload a video containing signs, language gestures to the system, and the model will analyze the video frame by frame. The CNN part of the model will extract spatial features from each frame, while the BI-LSTM part will capture temporal dependencies between frames. Together, they enable the model to recognize the signs present in the video. Fifth, WER, word error rate graph. Word error rate is a metric used to evaluate the performance of automatic speech recognition or sign language recognition systems. In the context of sign language recognition, it measures the accuracy of the system in converting the recognized signs into the correct words or sentences. A WER graph likely refers to a graphical representation of the WER over time or across different videos. It could be a line graph showing the WER values at different time intervals or for different test videos. The goal is to monitor the system's performance and see how well it handles the different signs and variations in sign language gestures. 6. Exit. The exit point simply indicates the end of the sign language recognition process. It could be a button or a command that allows the user to exit the application or close the system after they have completed their sign language recognition task. Coming to the execution part. To execute the project, first we need to open the code folder. Here this is the model folder. In this folder, we'll have .h5 files which contain the deep learning algorithms information. These .h5 files can be loaded into the project code during runtime to utilize the trained model for various tasks, such as making predictions on new data or performing specific operations. And these are some of the Python files which are containing the train and test data set over here. This Signum dataset has some folders including output data, which containing some images for the output data. In the raw images, we have some raw images. In test data, we have various folders which are containing the images over here for testing the dataset. And similarly, for training the dataset, in these all folders, we have some images which are containing the images for training the dataset. In this video, we have a video which we will upload in our project to identify the images or the signs made by the person. Here, this BI-LSTM and the predict, these two Python files are containing the Python script in it. Here, BI-LSTM is the main code file. And this is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. Now to run the project, double click on run.bat files to execute the project. This is the graphical user interface. With this, we are interacting with the program. Now click on Upload Signum Sign Language dataset. Here, this is the Signum dataset. Now click on Select Folder. Now click on Pre-processed dataset over here. Here you can see the size of the dataset 7260, where in this dataset we have total images as this, and total signs are 24. Pre-processing completed. Now click on Train CNN BI-LSTM Deep Neural Networks. Now here you can see that the model is generated and the detected error rate is 0.36%, and now we can see here the black screen to see CNN layer details. So in this screen we can see CNN different layers with different sizes of images to filter features and to choose best features for prediction or recognition. Here we can see in the first layer CNN has used 98 into 98 image height and width, and in the next layer it uses 49 into 49, that is height and width, and simply it goes on. Now model is ready. Now click on Upload Video and Recognize Signs button to upload video and to identify the signs. Click on Open over here. So we can see while video playing, CNN and BI-LSTM starts recognizing signs. Now click on Word Error Rate Graph button to view below error rate graph. Here x-axis represents iterative training values and x-axis also represents error rate. We can see when algorithm proceeds further with iterative training, then word identifying error rate down goes on. Now by clicking we can exit with our project over here. Coming to the conclusion part. In conclusion, our research endeavors to contribute significantly to the field of continuous sign language recognition by proposing an innovative deep neural framework that leverages iterative training techniques. By emphasizing temporal modeling, spatial features learning, multimodal fusion, and real-world application, we aim to build a robust and efficient system that reaches the lives of individuals who rely on sign language for communication. Ultimately, our work strives to make meaningful strides in fostering inclusive technology and empowering the deaf community in their pursuit of seamless communication and engagement.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.